Hi, my name is Jenna Saylor, and this is my physics lab report number 1 on charged tapes. Purpose of the lab: to observe the interactions between two charged pieces of clear tape, to determine how much excess charge is in one piece of tape, to create both an experimental and computational model, and to correctly answer the comprehension questions. Preview: the initial conditions of the tape were as follows. The mass was 2 times 10 to the negative 4th kilograms, the length was 0.2 meters, the width was 0.02 meters, and the final separation between tape A and tape B after they were both charged was 0.025 meters. And then as you can see on the right, we have the experiment results. We calculated the gravity, the electric field, the electron amount, the atom amount, and then the ratio of electrons to atoms. And then finally, we have our computer model results. We had the electric field vector, the relative position vector, the magnitude of R, the unit vector, and then finally the electric field vector. Some important concepts to understand are the Coulomb force, which is basically the force between two charges. Then we have the electric field, which is the difference between the observed location and the source, and then the field between them, so kind of what direction everything's pointing. And then finally, gravitational force, force equals mass times gravity. Experiment procedure. First, I cut a piece of tape at the correct length, and then I made a little handle so I wouldn't touch it, mess up the charge. Then I created another one, the exact same, placed it on top, rubbed it down, and then quickly ripped it off to charge the object. We knew it was charged if we held it by our hand and it was attracted to it. And from there, we repeated this to get another charged tape and held them and see how they interacted with each other and other objects. Okay, and now for the experimental results. A lot of the results that are listed on the screen were from the actual procedure and weren't necessarily needed in the lab report, so I'm kind of just going to skim over it a little. But as I said before, the two pieces of tape repelled each other because they had similar charge, and it's also important to note that anything charged object in a neutral object will attract because that sets the charge, but then if you were to touch it with your hand, the charge would disperse throughout the larger body and then go away. Also, the vertical forces on the floating portion of the tape were the force of the electric field from A, and then also the force of gravity, as you can see in the bottom right corner. And then also in the bottom left corner, you can see how we calculated the force of gravity. It was just the weight of the tape and then just acceleration due to gravity. And then finally, electric field, we use the formula I spoke about earlier, which is the K constant times the charge over R squared. And then finally, I just calculated the electrons through finding how many electrons were in a single Coulomb and then doing the calculations, which ended up being 1.44 times 10 to the 13th electrons. Now for the computer model. So as you can see at the beginning, we have our constants, our K constant, our protons, electrons. Then below it, we have the actual creation of the object, so we can see the sphere when we're looking at our code, the initial conditions of it, its weight, location, all of that. Then we have just R, our hat, getting the vector, finding magnitude. So then we can go ahead and plug it into the electric field, where we have another arrow pointing and just showing the reader. And then finally down here, we just have another particle, so then we can show the interaction between two like charges. Now taking a look at the bottom right corner, we have our results. As you can see, the first charge is the positive one, the electric field is going away. The second one is a negative, the field is going inwards. And then the third image are two like charges repelling each other. The magnitude of the charge on a singular piece of tape, according to the computer, was 1.15 e to the 10th coulombs. And then the assumptions made for the computer model were that there was no air resistance and that the tape had an evenly distributed charge rather than it being bunched up in a singular spot. And comparing our experimental model to the computer model, we can see that our numbers did slightly deviate. The computer model had larger final results than the recorded ones in the experiment, but despite that, we still had the same signs in the same results. So it still showed that the pieces would repel each other, and it did show that it had the same components for the electric field. Okay, what if? What if the electrons had a positive charge and the protons had a negative? What would change about the observations that I gathered? Nothing would have changed because either way, it's still the same amount of protons and electrons. So no matter what, it would still show the same results because they would still either repel or attract. It's just kind of flipped, but still the same. And then, why is it important to handle charged tapes as little as possible? What happens when it comes into contact with other objects? As I mentioned before, whenever it comes into contact, the electrons will move around and transfer, changing the charge. So you want as little contact as possible in order to prevent this from happening and skewing the results of your experiment. Finally, we have errors. I have limited coding experience, so if I was better at coding, I would have been able to write more accurate code towards real life. There also was a slight or a very high chance that tape had contact with other surfaces as I was moving pretty fast. Obviously, my hands probably touched it at some point, so it made the charge much weaker. Um, I could have had more precise numbers, longer numbers. The longer the number, the more accurate the answer. And then finally, there was still definitely air resistance. The end. Thank you.